Polars just crushed Pandas by 8.7 times on a 10 million row groupby. DuckDB, 9.4 times faster. These aren't vendor claims. These are reproducible benchmarks from multiple independent sources. I've been tracking the DuckDB and Polars hype train for 2 years now. Every week, another breathless blog post about the death of Pandas. But here's what actually matters. Real workloads, real data sizes, real memory constraints. So I compiled benchmarks from 6 different sources: academic studies, vendor tests, and our own reproducible harness. Let's start with the basics. Pandas executes operations eagerly and largely single-threaded. It assumes your data fits in memory. Polars is written in Rust with Python bindings. It leverages Apache Arrow for efficient memory representation. DuckDB is C++ under the hood. Uses a vectorized, pipelined execution engine with a cost-based optimizer. Look at this chart. We ran a real NYC taxi query on 3 million rows. Average fare, trip count, 95th percentile distance grouped by passenger count. Filtered to trips over 1 mile. Polars, 29 milliseconds. DuckDB, 38 milliseconds. Pandas, 220 milliseconds. That's a 7.5 times difference on a modest dataset. But 3 million rows is child's play. Let's scale up. On a 7 million company dataset, DuckDB completed processing in 3.8 seconds mean time. Polars took 5.8 seconds. Pandas? 19.6 seconds. The gap widens as data grows. At 100 million rows, the differences become stark. Group by operations, Polars finishes in 23 seconds. DuckDB takes 31 seconds. Pandas drags at 115 seconds. That's 5 times slower than Polars. Large joins plus aggregation on the same 100 million rows? Polars, 28 seconds. DuckDB, 35 seconds. Pandas, 162 seconds. Time series window operations show the same pattern. Polars leads at 26 seconds. DuckDB follows at 33. Pandas limps in at 129 seconds. CSV reading tells another story. According to CodeCut's benchmarks on 10 million rows, Polars reads 7.7 times faster than Pandas. DuckDB, only 1.4 times faster. But here's the catch. Who's still using CSVs at scale? In Parquet, the differences shrink dramatically. Memory efficiency changes the game entirely. On a 9 GB CSV with 67 million rows, Polars used approximately 0.5 GB peak memory with lazy evaluation and streaming. Pandas? It materializes the entire file eagerly into memory. No streaming, no lazy evaluation, just raw consumption. DuckDB takes memory discipline to another level, processing nearly 2 terabytes of data while keeping peak memory below 2.5 gigabytes. That's not a typo. 2 terabytes processed, 2.5 gigabytes RAM used. Try that with Pandas. On large join operations, Polars showed 30 to 60% lower peak memory versus Pandas. Pipeline to Insights found similar results. Loading a 1 gigabyte CSV file, Polars was 5 times faster while using 179 megabytes of memory. Pandas? 1.4 gigabytes. Here's what most benchmarks miss. Hardware dependency matters massively. DuckDB's groupby performance scales with CPU cores. On high-core machines, it flies. On a 2-core notebook, Pandas might actually win. Your MacBook Pro isn't a server farm. File format changes everything. Polars dominates CSV reading. But if you're already in Parquet, the advantage shrinks. Memory behavior gets misrepresented constantly. Polars' default memory mapping shows high RSS usage. But that memory is reclaimable by the OS. Misleading benchmarks everywhere. Failure modes reveal character. When Polars or Pandas hit limits, they crash hard. Out-of-memory errors. Process killed. DuckDB, it degrades gracefully by spilling to disk. Slower, yes, but it completes. The 10 gigabyte local versus 100 gigabyte cloud divide is real. Polars dominates on fast local SSDs. But cloud-native reads from S3? DuckDB's streaming architecture shines. Polars struggles with remote data. All 3 tools support Apache Arrow for efficient data interchange. 0 copy transfers between them. This isn't a winner-take-all game. It's about choosing the right tool for each stage. Here's my production playbook for 2025. Use DuckDB for SQL-heavy exploration and zero ETL querying of Parquet files. Use Polars for Python-first ETL pipelines where speed matters. Keep Pandas for quick prototyping and scikit-learn integration. Connect them all via Arrow. The 10 GB threshold is your inflection point. Below that, Pandas works fine. Above it, you're leaving massive performance on the table. 5 to 10 times slower operations. 60% more memory usage. Unnecessary infrastructure costs. Vendor benchmarks cherry-pick scenarios. Academic studies use synthetic workloads. Real production pipelines are messy. Mixed file formats. Varying data sizes. Different compute environments. Test with your actual data. The speed war isn't about crowning a winner. It's about understanding trade-offs. Pandas remains unbeatable for rapid prototyping and ML workflows. Polars excels at memory-efficient transformations. DuckDB dominates analytical queries and handles massive datasets gracefully. Subscribe to Workflow Logic if you want benchmarks that actually matter. Not vendor propaganda. Not toy examples. Real data, real constraints, reproducible results. Next week, why your data warehouse costs are tripling and what to do about it.